Hey guys, welcome back. We're doing another video here. I'm going over 5 questions for the at-home assignment number 15, System of Equations. This is the Classkick. So I want to do one from each section, and I'll probably help you set up the very last word problem as well. But this is just to help you check yourselves and understand the process. So let's do number 1 here. Again, you'll do this on your Classkick. I'm just doing it on a PDF to make it easier on me. So solve the system by graphing. So again, with this graphing here, we'll say the first one is red, second one whatever color. This is y equals mx plus b. Reminder, b is your y-intercept, and m is your slope. Again, slope is a change in y over change in x. So here, when I'm graphing this first equation, y equals negative 1/3 x plus 3. Let's start with our y-intercept. Our y-intercept in that case is 3. So 1, 2, 3. Next, use your slope. My slope is negative 1/3. So I'm going to rise 1 and then go to the right 3. 1, 2, 3. Rise 1, so rise just means up or down. So I'll go down 1 to the right 3. And then if I keep going in that direction, I'm off the grid. So then let's go back to our y-intercept. If I go up 1, I must go to the left 3. Since the slope is a negative, that means one of my directions I go must be in the negative direction. That's why here, since I went down is in the negative direction. The other direction must be positive. Here, since I went up, the other direction must be negative. Left is in the negative direction. Try your best to connect these dots. I know it will not be perfect, but again, just try your best. That's what we got there. Next one, we're doing purple. 1/3 x plus 1. So the plus 1 is your y-intercept. So that means we start at y equals 1, that positive 1 value. And my slope is now positive. So that means I must either go up and to the right or down and to the left. So I'll go up 1, 3 to the right, 1, 2, 3. Up 1, 3 to the right. Or down 1, 3 to the right. Down 1, 3 to the right. Again, just try your best. Well, will it be perfect? No. But make sure you at least see that the intersection is right there. So it looks like our solution is going to be the point 3, 2. And I'll get you set up with number 2. Number 2, what you must do is convert these two equations into slope-intercept form. So 2x minus y, I'll work that out over here up top. 2x minus y equals negative 4. To convert this to standard form, what I'm going to do first is I'm going to subtract 2x from both sides. So negative y equals negative 2x minus 4. Then I'm going to divide by negative 1. So y equals 2x plus 4. So that's my first equation. Y equals 2x plus 4. My other equation I need to move is that x minus 4y equals 12. Again, I want to get it in slope-intercept form. Slope-intercept form is that y equals mx plus b. So I need to get the y by itself. So let's move this x to the other side. Negative 4y equals negative x plus 12. And then divide everything by negative 4. So y equals negative 1 over negative 4 is now a positive 1 over 4. And 12 divided by negative 4 is negative 3. All right, so now we have here two equations. I'm not going to graph this for you. I want you to try to graph it yourself. But again, on your Classkick, you have the solution down below. You can check your graph on desmos.com as well. But we have our two equations right here. Sweet, we're solving number 3 and 4 by substitution. You must use substitution. As a reminder, substitution is you solve for x or y, and then you plug that back in to your other equation. Now, here in number 3, it's kind of set up already for us. We have 2x plus 2y equals 38, and then the other equation is y equals x plus 3. If we notice, the second equation already has y by itself. So that's good, that's nice. So let's take that first equation again. But now, instead of saying y, I'm going to now say x plus 3. I replace the y with an x plus 3. So y equals x plus 3. All that goes into here. I guess technically not this part here. But with that being said, now we have another equation with only one variable, which is good. That's what we want. Let's distribute this 2. So 2 times x is 2x. 2 times 3 is 6. We can go ahead and combine these two right here and there. So 4x plus 6 equals 38. And then to solve for x here, we'll get 4x equals 32. And then finally, to get the x by itself, we need to divide by 4. So we got where our value of x is. Now let's try to figure out our value of y. So our original equation was 2x plus 2y equals 38 and y equals x plus 3. To find our missing y, we're going to plug in that value of x into either equation. It doesn't matter which equation you use, but I'm going to use the second equation since it already has y by itself. So here, instead of saying x, I'm now going to say 8. Again, I found that 8 by doing substitution, that little long piece. And then we substituted the 8 into x, so we get that y is equal to 11. Therefore, my answer is the ordered pair 8, 11. Notice again how I put it as an ordered pair, because if I was to graph 2x plus 2y equals 38, and then I was to graph y equals x plus 3, they would intersect at the point at 8, 11. I'm going to get you set up on number 4, and then I'll let you do it by yourself. Again, solve for x or y in one of my two equations. It doesn't matter which variable you pick, and it doesn't matter which equation you pick. But be smart about it. I recommend picking the variable that has the smallest coefficient. In this case, my x has a value of 1, y has a 3, x is negative 3, and y is negative 3. I recommend solving for x in this first equation. Once I have that x solved for, I'm going to plug it into the second equation. So I'll help you go ahead and solve for x in this first equation. So to get x by itself, we need to move that 3y to the other side. So x equals negative 3y plus 1. So what I'm going to do next is, instead of saying, let me rewrite this here. Instead of saying x, I'm now going to say negative 3y plus 1 minus 3y equals negative 15. Notice again, we did the same thing like we did over here. We had already solved for y. The question gave me that already. I was nice to y'all. Here we plugged in the x plus 3 into our other equation. Then we started simplifying all that fun stuff to get our answer. Same thing here, except that I did one step in the beginning. I solved for x. And then here I'll plug it into my value of x. I'll let you solve number 4 by yourself. We got number 5, elimination. Elimination. Again, my goal with elimination is to, quote unquote, eliminate a variable. So what I mean by saying eliminate a variable is when I add my two equations together, one of my variables cancels out. So my two equations, 4x minus 7y equals 3, x minus 7y equals negative 15. So when I add these two equations on top of each other, I want either my x to equal 0 or my y to equal 0. And this one isn't too bad. You can, honestly, you can either solve for x here or y. It doesn't really matter. I recommend, though, solving for y because you don't need to multiply too much. I now need to ask myself, negative 7y plus a number needs to equal 0. So now I need to figure out what is that number. Well, negative 7y plus a positive 7y will equal 0. Okay, so then the second part of that question, how can I make this negative 7y a positive 7y? I'll say that again. How can I make that negative 7y a positive 7y? If I multiply it by negative 1, that would make it a positive. But again, what do you do to one part of your equation? You have to do to everything. So let me just rewrite these two equations for us real quick. So I'll do a purple one, why not? My first equation, notice I did not change it. So let's just leave it the same. But with the second equation, I'm now going to multiply everything in my second equation by negative 1. So negative 1 times x is just negative x. Negative 1 times negative 7y is a positive 7y. Negative 1 times negative 15 is a positive 15. Now look at this. My goal was when I add my two equations, one of my variables will equal 0. What happens when I add my equations now? 4x minus x is 3x. Negative 7y plus 7y, hey, that's 0. That's good. I want that to happen. And then 3 plus 15 is just 18. So now we got the equation. I'll just rewrite it to make it smaller. 3x equals 18. And then I feel pretty confident on I can solve for x here. So to get x by itself, we solve for x by dividing. 18 divided by 3 is 6. And we get the value of x. Now to find the value of y, we do the same thing like we did on numbers 3. And what you also would do in number 4. But plug in the value of 6 to either one of your two equations. Again, be nice to yourself. Pick the equation with smaller numbers. Wow, they're both terrible in this case. So let's just go ahead and pick the second equation because why not? So here, I don't like that color. X minus 7y equals negative 15. But instead of saying x, I'm going to now say a positive 6. And here, this isn't too bad because now we just need to solve for y. So let's move this 6 to the other side by subtracting. Negative 7y. So negative 15 minus 6. I'm taking that negative 15 and I'm moving it 6 in the left direction or the negative direction. So that is negative 21. And here, to get the y by itself, I'll go ahead and divide by negative 7. So y equals a positive 3. And please write your final answer in an ordered pair. 6, 3 is my final answer. I'll help you get set up with number 6, and then I want you to try it by yourself. Sweet. Number 6, negative 4x plus 9y equals 9, and then x minus 3y equals negative 6. Again, pick whatever number or whatever variable you want to eliminate. So when I add my two equations, I want x or y to be equal to 0. In this case, it doesn't matter what you solve for or what you want to eliminate first. And I'll help you out. I'll show you both options. So the first option is you can eliminate the x value. So if I want to eliminate the x value, I would multiply this bottom equation by positive 4. Now, here's what I'm going to do. I don't care which method you do. I'll show you both options. So this would be option number 1. This would be option number 2. And let me just give me some space here, just because I'm going to need to have some room. So if I was to continue on option number 1, and now if I was to multiply this bottom equation by positive 4, I would end up getting, let me just rewrite my first equation, a 4x minus 12y equals negative 24. Then I would just go ahead and add my two equations and then just solve for y. So this would be negative 3y, negative 24 plus 9. That'll be just a, why am I blanking on this? That'd be just a 15. Or negative 15. So that's option number 1. And then you would continue on with option number 1 like we did over here. I'm not going to finish that. I want you to do it by yourself. Or you can do option number 2. So we had our original equation, negative 4x plus 9y equals 9. And then 4x minus 3y equals negative 6. So instead of eliminating x, what if you want to eliminate y? So you can multiply both sides of my equation, let's say by 3. The reason why I selected 3, because when I distribute that 3 to everything inside the parentheses for my second equation, first equation stays the same. My second equation now becomes 12x minus 9y equals negative 18. And look what happens now when I add my two equations together. A negative 4x plus a 12x, is just an 8x. The 9's cancel, the y's cancel, and we get a 9 minus an 18, which is negative 9. Now, again, it doesn't really matter what method you do or what method you select. That's on you. You do what you think is best for you. Again, you pick whatever method you like the most. But let's finish up. Well, actually, we have a couple more. So we have number 7 and number 9 and 10. So for number 7, I want you to solve it by graphing. Now, for some reason, that says y equals 2x plus 5. That should be a inequality. While I get this pulled up here in the meantime, we are going to solve this regularly. So inequalities have multiple answers. Inequalities do not have one answer, they have multiple answers. That's why we do a bunch of shading. So here to draw this graph, y is less than negative 2x minus 3. We're going to do it just the same way we've been doing. So first, what I'm going to do is find my y-intercept, which would be negative 3 in this case. And then here my slope would be negative 2. So m is negative 2. Remember, it's a negative 2 over 1. That means for my rise, I'm going to go 2. My run, I'm going to go 1. So if I go down 2, I'll go to the right 1. Down 2, right 1. Or I can go up 2 and to the left 1. Regardless, I'm just going to keep trying my best here. Now, this is for an inequality, so you need to look at the sign. The sign here is less than. Ask yourself, less than, is that a solid line or a dotted line? Is it solid or dotted? Since it's not equal to, that means it's a dotted line. So try your best to make it just a dashed line here. Perfect. That means solutions do not lie on this line. Okay, so as y is less than this line. So for shading, I'm going to shade below this line here. Again, it's not perfect, but just try your best. And then again, for some reason, my second equation is y equals 2x plus 5. Probably just a typo. It should be less than. So here, I'm going to graph the line y is less than 2x plus 5. And we'll use different color. We'll use green. So with this here, y is less than 2x plus 5. Again, start at your y-intercept, which is a positive 5. 1, 2, 3, 4, 5. My slope is a positive 2. So that means it's a 2 over 1. So if I go up 2, I'll go to the right 1. If I go down 2, left 1, down 2, left 1, down 2, so on and so forth. Try your best to connect the dots. There we go. Ask yourself again, okay, do I have a solid line or a dashed line? Since it's less than, that means it's a dashed line. I'm actually going to redraw this line now with just a dash, just because I don't want to erase it, the shading. Perfect. And then finally, ask yourself, do I need to shade above this line or below it? I'm going to shade below this line because it is less than. And I'm not going to do this perfectly, but you get the point. And it's actually a really cool thing that we picked these two equations. Because you may want to think that your answer is this order pair here. That is not your answer. The order pair -2, 1 is not your answer. Your answer is actually this whole section that is double shaded. And then you might ask yourself, well, technically, isn't that point -2, 1 in a double shaded area? It's actually not. And the reason why it's not, because our lines here are dotted or dashed. The reason why we do dashed lines is because the dashed lines signify that our line does not have any solutions on there. So all this stuff here on this line is not a solution. All the stuff here on this line is not a solution. That's why we have it as a dotted line. Number 8, again, I won't help you with this one, but it's very similar. And both of them are already in slope-intercept form, so you don't need to move from standard to slope-intercept form. I'll do number 9 and help you get set up with number 10. So number 9, Casto, I guess, and Gabriella are selling pies for a school fundraiser. So customers can buy apple pies and lemon meringue pies. So Casto sold 6 apple pies and 4 lemon meringue pies for a total of $80. Gabriella sold 6 apple and 5 lemon meringue for a total of $94. What is the cost of 1 apple pie and 1 lemon meringue pie? So we have our 2 different pies here. We got ourselves some apple pies and lemon meringue pies. So we'll say, I guess, A is apple. That makes sense. Apple pie. And L is lemon meringue pie. Cool. So here, let's start off with Castle. Castle here, when he sold his stuff, so Castle, he sold 6 apple pies, 4 lemon meringue, for a total of $80. As opposed to Gabriella, I'll put Gabe because I don't want to write out Gabriella. She sold 6 apple pies and actually 5 lemon meringue for a total of $94. We have our system of equations here. Now, notice the question didn't say what method to use to solve this. So you can actually use any of the 3 methods. I mean, if you want, you can solve this by graphing, or you can solve it by substitution, or you can solve it by elimination. It doesn't matter what method you do. Just to save time, I want to use elimination. The reason why is I want to eliminate A. So let's eliminate our apples. So here, if I was to eliminate A, I want to say 6A plus a number is going to equal 0. So 6A plus a number equals 0. Well, let's just do the opposite of it. What if we did 6A plus negative 6? That would equal 0. So how can I turn this 6A into a negative 6A? Let's multiply it by negative 1. So let me rewrite my equations here. My first equation is 6A plus 4L equals 80. And my second equation now becomes negative 6A minus 5L equals negative 94. I went ahead and distributed this negative 1 to every single term. This is good and great because when I add my two equations together, 6A minus 6A is just 0. And then 4L minus 5L is just a negative L. And then 80 minus negative 94 is just a negative 14. And then to solve for lemon meringue, I would just divide both sides by negative 1. So L would equal $14. That should be a 1. $14. So here, again, like we did last time, once we found a value, we'll just plug it in to either equation. So let's plug in the 14 towards, well, I guess these numbers are a little bit smaller. So let's use the first equation. So 6A plus 4L equals 80. But instead of saying L, I'm going to now say 14. Again, I found the 14 by doing that process of elimination. Now let's just solve for A. 4 times 14 is 56. To get A by itself, we'll subtract 56 from both sides. We'll get that 6A equals 24. And then here to solve for A, I'm going to say A is 8 because I divide my 4. Because I divided both sides by 6. So, and then go ahead and write out your final answer. With this here, apple pies are $4. And then lemon meringue, it's a long word, I know. I think I spelled that wrong, but that's fine. Are $14. That's really expensive, but I guess they must be good or something. I hope you get set up on number 10, and then from there, I want you to try to solve it from yourself. Okay, so 10, the length of a rectangle is 4 centimeters longer than the width. The perimeter of the rectangle is 80 centimeters. And find the length and width of the rectangle. So in this question, I actually already gave you one of the formulas or one of your equations. So notice here I told you, hey, in case you forgot, perimeter is found by doing 2L plus 2W, where P is perimeter, L is length, W is width. So I gave you the equation that, hey, 2L, I don't like that L, 2L plus 2W equals my perimeter. But ask yourself, do I know the perimeter of my rectangle? I actually do. I know my perimeter of rectangle is 80 centimeters. So here, instead of saying P, I can now say 80. Okay, so that's one equation. Let's find our second equation. So let's look at the first sentence. The length is 4 centimeters longer than the width. Again, it says the length is 4 centimeters longer than the width. So what is longer? The length is longer. And in fact, how much longer is the length than the width? Is you take the measurement of the width and you add 4 to it. Again, you take the measurement of the width, add 4 to it, and that's your length. Now, again, I'm not going to tell you a method to use to solve number 10. I recommend substitution because it's kind of nice. If you did substitution here, that's a bad L. Instead of saying W, I would just now say W plus 4. I'm not going to finish that because I want you to try by yourself. But that'll be it for number 10. In case you're wondering here, the correct answer, clearly the best answer, if you deviate from this, you're clearly wrong. I'd say Whataburger here, Chick-fil-A. Yikes, Chipotle. Yeah, Chipotle. If not, I might have said Taco Bell or Panda. Yeah, that's a hard one. But yeah, so that is it for assignment number 14. Let me know if you have, assignment number 15. Let me know if you have any questions about what to do next for numbers 2, 4, 6, 8, or 10. Or if you want to argue with me about number 11, you can do that as well.